Okay. Okay, we're starting to record now. I'm now very pleased to introduce our speaker for this evening. Rob Deaville is Project Manager of the UK Cetacean Strandings Investigation Programme, which is coordinated at the Institute of Zoology. He's been helping to investigate the causes of marine strandings around the UK since 1998, and we're really delighted to have him here to share his expertise with us this evening. I'm going to stop sharing my screen now, and I'm going to hand you over to Rob.
Thank you very much. Let's see if I can get this to work. How do I turn off this poll? Continue. Okay, get rid of that. Share screen.
Oops, we seem to have the poll results popping up. Okay, that looks kind of like it's coming fine.
Great. Through. Everyone got that? Great.
Yeah.
Hello, everyone.
Okay. I seem to have quite a lot of layers on rather than the actual talk at the moment. So I think we're sharing. Right, this is better. And then yeah, perfect. Lovely. Thank you very much. That looks great.
No worries. Technical hoo-ha, right? How do we cope in a pandemic? Evening, everyone. So my name is Rob, and for my sins, I have been working on strandings in the UK for the last 21 years. And tonight, this is sort of layout of what I'm planning to do this evening. I'm going to talk about the history and background to the programme. I'll talk about our work over the day. I'll talk a little bit about strandings in the Thames, given your background within the group as well. And I'm hopefully going to be able to share with you what our work means and what it can tell us about the threats that these species face around UK waters and the wider threats to the marine ecosystem itself. And just to flag up, obviously, strandings are opportunistic in nature. We depend on things washing up, but they're still the only means we have of assessing the threats on some of these species. And as Maria said, public health warning. By the nature of our work, we do carry out post-mortem examinations. There will be some gory slides on this. I hope you'll bear with me because there is some context and value to what I'm going to show you this evening, I think. Okay. What do we mean by strandings? This is what we mean by stranding. Essentially, it's when a marine. This is an aerial shot of some sperm whales on the English coast a few years ago. And this is a famous wood carving of a famous mass stranding of sperm whales on the Dutch coastline in the 16th century. That makes me make the broad point that strandings have occurred throughout recorded history, and they occur anywhere we have coastline. And they can occur singly or in groups when you get mass strandings. And essentially, programs like ours, because there are many around Europe and around the world, we investigate stranding events, try and work out causes of death, and then from that, the threats these species face around UK waters. Which ones die due to man's activities, which ones don't? And that's what we're going to try and bottom out this evening. Okay, some background, first of all, to strandings in the UK, going way back to 1324. There's this awful term called royal fish, which was enacted by Edward II in 1324, and that was for food. So essentially, a soldier would turn up and then chop the dead dolphin in half. He would have the head, the queen would have the tail. So theoretically, that royal prerogative is still in place. So much like Swan, theoretically, Queen Elizabeth owns all the strandings around the UK coast. Thankfully, she doesn't turn up that often and allows us to get on with our research. So moving forward a little bit further, in 1911, there was a mass stranding of 50 pilot whales in Penzance in Cornwall. This is an extraordinary picture of that mass stranding underway, with the response from the local public not perhaps being the best response in the world. And thankfully, things have moved on since then, and I'm going to come back to that a bit later on. But it got our predecessors at the Natural History Museum thinking what a great resource strandings would be to try and actually learn more about species which are actually quite hard to study in the wild. So from 1913, they began to routinely record data on strandings around the UK, and thanks to them, we have a very long-term data set now in the UK. And they also began to recover animals for skeletal preparation, which now form part of the Natural History Museum's collection. So 2 examples to talk about. The top picture is a northern bottlenose whale, which stranded in the Humber estuary in 1937, was transported to London, unloaded at King's Cross, driven across rush hour traffic on an open flatbed truck, and then dissected on the front lawn of the Natural History Museum. For those that are Londoners, this is the Queen's Gate entrance. So pretty fragrant afternoon in South Kensington that day. And the bottom picture shows a sperm whale, which skull, which had been buried underneath the Naturalists Museum lawn, dug up a few years later, defleshed, and that now forms part of the prep at the Naturalists Museum. But the modern program that I'm involved with actually began in 1990. So before I move on, just in terms of historical context and just to set the scene, as it were, I'm going to talk about 3 strandings in quote marks to try and draw out some of the background and relationship we have had in London with strandings in the past. So there was a famous stranding of a North Atlantic right whale, NARW, in 1658, famous historical account set upon by the local population, dragged ashore, butchered, and then taken apart for the oil within the animal. And that history, that past that we had in our relationship with whales in London, was borne out quite graphically by the discovery of the dismembered remains of that whale at Greenwich in 2010. And that's an amazing picture of the discovery of that whale. And that was cleaned up and then taken into the prep museum's, National Museum's collection as well. And that bears butcher marks from the public taking it apart on the foreshore. This isn't really a strand being unloaded at Dagenham in 1954. Jonah was a whale that was hunted near Iceland, embalmed in formalin, and then traveled around the country as a travelling freak show to entertain and delight the public, as in this bottom picture here. And then I'll contrast that with the response in 2006 to Northern Bottlenose whale, which came up the Thames. There's a very large-scale rescue attempt that I was involved with. Obviously, that rescue attempt didn't succeed because the animal unfortunately died in transit out of the Thames. But the point I'm trying to make here is that the response to the public was astounding that day. And we have changed from a nation of whalers to a nation of gawkers to now a nation of conservationists in a really short time frame. And I know I don't have to tell you all that. All right, before I move on from so 2 species, the fin whale, top animal here is a fin whale, and the humpback, bottom animals there, humpback, in blue and red. This is the 100-year time series. No humpback whale strandings at all for about 80 years. And then this green line is when we banned, signed into effect the moratorium on whaling in 1986. And because of that large-scale ban that's now in place across the world, some of these populations are beginning to increase. And in some instances, are actually now back to close to their pre-whaling levels, particularly for the humpback whale. And that's really good news. And as a side effect of that, we have begun to see strandings in the UK. So over the last 30 years, we've now had about 30 to 40 humpback stranded around the UK. And I suppose this makes the broad point that strandings aren't always bad news. They could be evidence of a recovering or a healthier population. And actually, as a conservationist, it's where we don't see strandings, we might have much more cause for conservation concern. All right, this is the shape of the modern strandings program in the UK. There are 6 main partners. I work at the Zoological Society of London. All the partners are arrayed down here on the bottom. We have our funders within government, DEFRA, Welsh Government, Scottish Government, JNCC manage the program, but there's a whole range of voluntary or statutory institutions and groups around the UK that all have some involvement or buy-in in terms of stranding response around the UK, and we all work very closely together. So this is the shape of the modern strandings program. This flow chart outlines the broad process. You don't need to worry about that. Put very simply, we get a stranding event. I guess the first question is, what is it? Where is it? Can we safely access the body? And if we can we safely recover it as well? And these can be quite long and drawn out recovery processes to get it from the beach to one of our post-mortem facilities in the UK. If we can recover it and get it back to one of our labs, we then carry out a systematic and forensic post-mortem examination that is in many ways more detailed than a human post-mortem because of all the data we collect. And that will hopefully then generate cause of death. And that gives us the individual building block upon which we build the rest of our research. Normally not that quick though, a little bit slower. Okay, this table shows the number of strandings over this 30-year period. And for the rest of the talk now, we'll talk about this 30-year period from 1990 to 2019, around about 17,000 strandings of cetaceans, the large majority of which are animals found dead on the shore. Nearly 90% of all strandings appear to be dead stranding events. Significant number, though, of live stranding events. This is the Thames whale I mentioned earlier. and then some animals found either entangled or floating dead at sea. And that's the makeup of our strandings data set in the UK. And I guess the other take home is there's been 22 species of cetacean recorded in the UK over that 30-year period. And that's around a quarter of the world's known total. And I say known because we're still discovering new species of whale, which I think is rather cool. And that diversity of species around the UK reflects our quite unique position in Northwest Europe. We have a range of habitats. We have shallow coastal waters where we get things like the harbour porpoise. We have more pelagic or deeper waters where we get things like common dolphins and baleen whales, and then very deep continental shelf edge where we get species like sperm whales and beaked whales. All of those species are found within the EEZ that belong to the UK. So we're quite lucky and fortunate to have that diversity of species in our water. So the mass stranding events are events of animals to get proximity. It shows those events with the size of the circle denoting the size of the event. We've obviously had some period. The video running on the right shows a mass stranding of pilot whales in 2011 in Durness up in northwest Scotland. In 2008, we had a mass stranding of common dolphins in Cornwall. And 2012, another mass stranding of pilot whales in Pittenweem in southeast Scotland. More recently, a mass stranding of pilot whales up in Skye. We had a couple of more mass strandings of common dolphins in other parts of the country too. Now, in all those events, rescue groups responded and managed to refloat a large proportion of those mass stranded animals, which is great. So those are groups like British Divers Marine Life Rescue, RSPCA, SSPCA, and so on. So thanks to their efforts, a large number of animals were rescued and refloated, but a large number did also die. We investigated all those mass stranding events. Long story short, 2 of them had an association with man-made noise, and there are links on the bottom of the slide there to those papers if you want to learn more. Before I move on, it's worth saying we also, beyond just cetaceans, we also work on a variety of other taxa. I'm not going to talk about turtles, sharks, but if anyone wants to know more, drop me a line. I'm happy to fill in more information on those as well. All right, so this graph shows the number of cetacean strandings over that 30-year period. Bluish color are all cetaceans. Dark purple is the most numerate, most common species, the harbour porpoise. And then the pale yellow, that's the second most numerate species, common dolphin. So lots of interannual variation, but certainly over the last few years, the mean numbers approached nearly 1,000 over the period 2016 to 2020. That should be 19. I just noticed that error rather than 29, not forward looking.
Rob, can I just briefly interrupt?
Yeah.
Rob, sorry. We're just having a bit of interference. So could you try turning your video off and just see if that helps with the sound quality? You're occasionally turning very metallic. So if you
me. All right, let's try that. Is that any?
Thanks.
Okay. Do shout out if you've got any problems. I am unfortunately having to run this through my phone because the internet's not working here for me. So hopefully it works all right. Okay. So where are we seeing strandings around the UK? We'll put the 2 most common species side by side, the harbour porpoise and the common dolphin. Porpoises are coastal, so we find them UK wide. We even find really determinedly suicidal animals, well, like river systems like this animal here. And in contrast, the common dolphin, it's much more spatially explicit. Down here in the southwest region, and then along the coast of Wales and the Channel coast too, but really down here. The interesting thing is we have a large transect running north-south, and we can see changes in distribution over time. We're seeing increase than we ever used to see, and a reduction in strandings of colder water species, things like white-beaked dolphins. So there's an increase of strandings in warm water species, a reduction in strandings of cold water species. That's all potential evidence of some climate change-driven impacts, and there's a link to a paper we had published a few weeks ago there to illustrate that. But this is the kind of the meat of what we do at the Institute of Zoology and our partners too. We carry out post-mortem examinations. I've aggregated a large number of those causes of death in some very broad categories, just to give you an indication of the kind of threats or pressures that we deal with. I've taken out here animals that we know have been caught in fishing gear. This is just from stranding animals. And there's some pictures to illustrate that on the right. And I'm going to run through a few of those in a bit more detail. Before I move on, it's worth just mentioning though that there's this big misconception that all stranded animals are sick or compromised or debilitated. And in fact, our data shows that over half have died due to some traumatic driver of mortality, and they're therefore more representative of the wider population as a whole, which is useful to us as scientists. So this is the major man-made pressure that we deal with in the UK. Bycatch has global impact on cetaceans. This is, sorry, just to spell it out, that's when animals are accidentally caught in fishing gears. So it's the accidental capture of non-target species. So this is a harbour porpoise caught in monofilament gill nets with characteristic net marks around the head. And then this is a common dolphin at the underside of the head with multi-filament braid impressions running over the mandible. So different kinds of fisheries cause different kinds of injuries. And I've just summarized those cases with some very simple statistics. So number of cases of bycatch, number of postmortems, broad proportion of bycatch within each of those species that are affected. And you can see that most cases occur in harbour porpoises and common dolphins, and I'll talk a little bit more about those two species. So where do we see them? Harbour porpoise bycatch is UK-wide, but highest numbers in the southwest Cardigan Bay, southeast part where I'm based, we're all based, and then historically on the northeast coast of England, quite low numbers in Scotland, and that perhaps reflect we have highest levels of fishing effort that might affect or particularly implicated in bycatch of porpoises. In contrast, common dolphin bycatch really spatially explicit. It's down here in the southwest, primarily Cornwall, every year, year in, year out. We unfortunately have a bycatch season. From December to April, we see large numbers of animals washing up with evidence of bycatch. This figure shows the broad proportion of bycatch expressed as a proportion of all other causes of death. So how common is it within those two species? Again, common dolphin in blue, porpoise in red. Lots of interannual variations, some years of very high numbers. So you can see 1992, quite high mortality, about 80+% associated with bycatch, again in 2003-4, and then it's declined somewhat in recent years. This green line is when there was a ban on a particular form of fishery off the southwest, in part driven by our research. And you can see that post that has been an associated decline in common dolphin bycatch, but it may well have just pushed the problem further offshore. So I'm not saying it's solved it completely. So entanglement is a form of bycatch, but it's quite specific to larger whales. This is a Minke whale with rope marks around the tail fluke. And so that was an acute form of entanglement. That animal drowned acutely in ropes. But this animal we think was chronically entangled. This animal stranded alive, another Minke whale, and whatever it had become entangled in had partially sawn through the mandible on one side and completely on the other side. It was really thin, really emaciated, had an underlying infection, not surprisingly because it got a massive open wound on the head. So this is a severe welfare problem for those animals that are affected by chronic entanglement. And you can see the number of cases in that table. If we map them out, we can see that it's really a Scottish facing issue. So most cases occur in Scotland, and that's where we have the highest density of Creole type fisheries, which we think are implicated in those entanglement cases. Ship strike, self-evident what that is. Here's a common dolphin that's been hit by propeller blades, and then a fin whale that's been hit and killed by a cargo vessel crossing the Atlantic. A number of cases, again, given in that table. If we map those cases out, we can see the UK-wide, but we do have higher densities around port regions, around London, and around the 5 ports on the Harwich port, sorry, on the eastern English seaboard. So perhaps higher densities around areas where we have higher shipping activity, which isn't totally surprising. But the numbers, just to note here, are fairly low in terms of the overall makeup of the data set. I'm going to pause for a second and move away from the depressing man-made drivers of mortality and talk about something that's more natural or naturally occurring, and the issue of inter or intra-specific aggression. So we've got two issues here that we're dealing with: a fatal attack from one or more bottlenose dolphins, and there's a definition, or grey seal predation. And I'm going to talk just about bottlenose dolphin attack, but just to point out the numbers here are quite high, 463 cases, of which the large majority are bottlenose dolphin attack cases. So it's a fairly significant cause of death in some of the animals that we look at. So what do we mean by that? So we get porpoises, for example, washing up with rake marks on the outside. Rake marks are made by cetacean teeth interacting with the skin. You can see the parallel marks here on the skin, and these are fresh, so they've occurred recently. Here's a close-up and a further close-up still of one of those sets of injuries. What happens is the tooth pops into the skin, tears out, and you're left with these parallel tracking marks. And we can see here the characteristic three-cornered tear where the tooth has popped to the skin. When we open the body up, you'll see external, no damage to the skin, but underneath in the blubber, we have these shearing damages where it's consistent with blunt force trauma, where it's been hit with a focal injury. We get shearing of the blubber layer, and then fills full of frank hemorrhage. The hemorrhage then tells you it's happened before death. And the animal usually gets hit more than once. So it's not like ship strike where it's blunt force trauma over the back. This has been hit multiple times usually around the chest cavity. And when we open up and take away the blubber layer, we find these depressed areas associated with uni or bilateral rib fractures. So it's quite a violent and traumatic cause of death. And then when we map the cases out, as we have done here, there are clusters. So we see them around the Moray Firth region historically, Cardigan Bay, more recently around southwest England. And also my manor, I live in Brighton, so we've begun to see cases in Brighton as well. And these are areas where we have an overlap of populations of both bottlenose dolphins and harbour porpoises. So we proposed back in the day that bottlenose dolphins were attacking and killing harbour porpoises, and it wasn't really until a video like this was obtained that we managed to confirm that. This is a historical video showing 2 attacks of bottlenoses on harbour porpoises, and then slowed down again. You can see the size disparity. The poor porpoise is much smaller than the bottlenose dolphins. They're hitting them with their rostrum, targeting probably with their sonar, knocking them out of the water. As soon as they hit and kill the animal, as soon as they kill the animal, they lose interest and swim off. So it's not for predation, it's some other driver going on here. Okay, so it's been seen many times, witnessed directly around the UK. This is a more recent attack in Cardigan Bay, witnessed by colleagues at Sea Watch. And they also practice infanticide. So we have similar sets of injuries washed up in Scotland and in Wales too. So lots of different theories around why this is happening. Before someone posts a question in the chat, lots of different theories. I guess the current thinking is this is probably some sexually driven characteristic, because all the witnessed attacks that have happened, or nearly all of them, have occurred in subadult to adult males, and it's therefore perhaps more likely that it's some sexually driven behavior that then might be transferring onto the porpoises. But the jury's still out on exactly why that's occurring. But I'll just flag this up here just to emphasize that it isn't just us that find inventive ways, unfortunately, to kill cetaceans. They also do it quite well themselves as well. All right, so this is a Cuvier's beaked whale that stranded in Skye in 2015. An adult male Cuvier's, it repeatedly life stranded. So ultimately it was euthanized by shooting because it was not appropriate for further refloat attempts. There was an underwater post-mortem carried out by our colleagues in Scotland because the tide was coming in. During the course of that examination, they found large volumes of plastic in all the stomach compartments, running through the communication between the stomachs and into the first part of the intestine. And my colleague Nick is holding the large amounts of debris or plastic in his hands when he got back to lab to take some more pictures. It's worth flagging up that animal also had some underlying kidney pathology, which may have brought it closer into shore. And perhaps what we're looking at is aberrant feeding because they may be taking in plastic accidentally closer to shore. So this looks quite dramatic. And I guess the question is this significant? We've all seen the Blue Planet and the issues highlighting quite rightly the problems with plastic in the marine environment. Well, actually, we only had a couple of cases, and that's one of them, of debris ingested related mortality in over 4,000 postmortems over 30 years. So this is a partial aggregation of that data set, just for an 11-year period from 2005 to 2015. We're still working the rest of the data up for a paper, but it shows you that over 1,400 postmortems, we only found plastics in 35 cases. I'll give you some examples. This is the first stomach, because cetaceans generally have 3 stomachs, of a porpoise with a small crisp packet fragment, a northern bottlenose whale with some plastic sheeting and some fragments of netting, and then a small plastic wheel in the stomach of a sei whale. And I hope it's obvious here that we would consider this a secondary finding. It's obviously not ideal to have plastic in your stomachs, but it certainly hasn't been a causal factor in those animals' deaths. It hasn't caused an impaction, and therefore it hasn't led directly to the deaths of those animals. What I will say is that there's evidence that within our cases. I've highlighted here the deep diving beaked whales, which are all suction feeders. There's evidence of a higher number of cases of debris or plastic ingestion in those animals. And there's evidence that in marine canyons, we have much higher levels of plastics. And as this is a critical habitat for beaked whales, they're perhaps more at risk of accidentally taking in plastics. We don't see many beaked whales in the UK, nor can we get to those that do strand, because they're often quite decomposed. And therefore, perhaps this could be an underreporting of the issue, which could be much more significant out there. So I do leave that hanging and flagging it up. It highlights the importance in science of collecting negative data. We need to know where things are a problem as well as where they're not. So just to be clear here, I'm not saying plastic is not a problem. It's just for us in the UK, in the North Atlantic Oceanic Basin. Our colleagues in the Mediterranean see much higher levels of plastic in the same species they study, because everything
Hi, Rob. We seem to have lost your sound.
Plastics. That's an issue that was okay. Good. Right. Can you hear me? Can you see me?
Yeah, we can hear you and see you. We lost about probably about a minute just of your sound.
Technical issues, right? Okay. I'm just going to try and reboot that, and we'll try running it again.
Yeah, that's fine. That's fine.
Right.
No worries.
Okay. Can everyone see that? Got it back?
Yeah, that's fine. And can we just go back to the slide before that? Because I think we probably missed your last couple of sentences.
I don't have anything to say anyway, so that's fine. So say when, tell me when to stop. About there?
Yes, we got yeah, no, on that one. And then you were just talking about the negative data, you know, that the about the kind of plastics.
Yeah.
It was important to get negative data. And then I think we lost maybe a couple of sentences.
All right, bear with me. Okay, so I'm just going to
we saw all that, and you pointed out about the beaked whales, and it might be more significant for those, and then you just started talking about negative data, but I don't think maybe it was the sentences about the microplastics that we didn't hear.
Okay, well, I didn't have much to say actually.
Okay,
all I was flagging up is that
Thanks
everyone,
anyway.
No problem. It's good to know. Important, right? The issue of microplastics, nanoplastics, everyone will have heard of, and that's something that we're actively pursuing within the network, trying to learn more about that. So again, just to be clear, I'm not saying plastics are not a problem. It's just from the perspective of what we work on in the UK on cetaceans, it doesn't appear to be a significant or common finding. Okay, so I'm going to move on to some gory pictures now. Forgive me, bear with me. So disease is the most significant or common finding across all species. So just some examples. This is a harbor porpoise with parasites in the airways, and we saw some of these in the examination this morning we carried out at ZSL. This is a kidney in cross section with a large abscess from a harbor porpoise again. This rather grim picture is the first stomach of a common dolphin full of parasites, a species called Anisarchus simplex, which also affects humans. If you have too much sushi, you can get anisarchiasis. Word of warning. Not in the UK. I should probably say that before I get sued by the sushi industry. And then this large, spectacular looking lesion is an abscess on the ventral side of a Minke whale. This is associated with an infection with a bacteria called Brucella seti. So as I did with the bycatch cases, I've lined these up so you can see the broad proportion of disease-related mortality. There's a couple of outliers. Striped dolphins, white-sided dolphins have quite a high proportion because they're quite prone to brain infections with a particular bacterium. But I'm going to focus in again on the porpoise and the common dolphin, the most common species we see. We do see a higher level of disease-related mortality in our coastal porpoises compared to our more offshore common dolphins. And I guess the question would be why is that? Well, we've been quite fortunate to have lengthy funding from DEFRA and have, with that and with the collaboration of colleagues at CFAS, have generated the world's largest data set on marine contaminants in cetaceans. So what I'm going to get at now is pollution causing an impact on these animals as well? So this is a figure from a paper we published a few years ago, quite an important paper, and I'll walk you through it because I appreciate it's a bit complex. We're talking here biphenyls. They're part of a group of legacy pollutants, persistent organic pollutants, but legacy because we banned them 30 or 40 years ago, but they're still causing quite serious effects. They bioaccumulate, so higher up the food chain you go, the higher the impact an issue with these pollutants may be. And they have two effects. They affect the immune system, so you get immunosuppressive effects. Essentially, you get diseases like the pictures I just showed you. And you can also get reproductive impairment. What that means is you get a drop off in young being born to a highly PCB exposed population. So we've got 4 cohorts here. We've got harbour porpoises from the UK, and then the y-axis is mean PCB levels expressed as a proportion of the blubber that we examine. Striped dolphins in the Western Mediterranean, bottlenose dolphins from around the European range, and then killer whales from around the European range as well. And I've got here 2 lines. These are theoretical threshold of toxicity. So the lower yellow line is the lowest level, and the red line is the highest level we could find in the literature anyway. And the idea is that if you have levels above these thresholds, you significantly increase your risk of developing disease and ill health because of your PCB exposure. And we can see that porpoises are hovering around the yellow line, but these other species, these other groups are way above them. And in some instances, like the killer whale, they're much higher, an order of magnitude higher than some of those thresholds of toxicity. So when we published that paper, there's some quite hyperbolic reporting, as in this Guardian headline. But I'm going to break the fourth wall now and talk about an individual animal, because you not do that in science. This is Lulu. Lulu belonged to the last remaining killer whale pod found around UK coastal waters. This is the West Coast community, which is normally found around the Western Isles. It's been heavily studied by the Hebridean Whale and Dolphin Trust for 30 years. And Lulu died due to entanglement. She died due to entanglement in creolines and was found stranded in Tiree, Scotland in January 2016. But the fact she was entangled was almost incidental. When we measured her blubber levels, they were 1,000 times higher than the threshold I showed you in the last slide. So one of the highest levels ever recorded in any mammal on the planet. And her ovaries were non-functional. So even though she was at an age where she should have been happily having calves, she never had. And that population, as I say, has been studied for 30 years, never had a calf in all that time. And so that population will go extinct probably in my lifetime or our lifetimes. And then there will be no more coastal killer whales left, sadly, around the UK. I'm going to pause just the last 5 minutes, if I can beg the panel's indulgence, and just talk a little bit about Thames strandings, given the group's interest. So what I've done is pull out data here on strandings around the Thames region, also including parts around Kent, Essex, and the Thames wider estuary. These are harbour porpoise strandings. That's the large majority of strandings we see around the Thames region, even well up the river system. So that's the most common species we see. Probably about 400 or 450 out of the 500 strandings we've had have been harbour porpoises, and they are commonly found within the Thames estuary. Less commonly seen, though, are the variety of other species. I haven't given a key here, but just to flag up, there's been a wide variety of other pelagic species which don't necessarily belong in the shallow southern parts of the North Sea. And so when we get things like a minke whale up the Thames, or like a sperm whale in the Swale, they don't belong there. They are aberrant out of habitat species which have ended up within that Thames region, and sadly and unfortunately there's usually only one outcome when they end up around the Thames. But just to try and not be too depressing, I want to flag that the Thames is obviously alive and well, and ZSL runs a sightings database looking for marine mammals around the Thames estuary come in and out of that outer estuary quite happily. I'm going to finish though by talking about 2 high-profile strandings that occurred in the Thames, and give a slightly contrasting story for each one, which might then help illustrate why there's an issue potentially within the Thames region with these larger animals. So this is a humpback whale, which was seen on the 6th of October in 2019, behaving morbidly. What I mean by that is seen swimming and slowly listing to one side, as in this picture here, shot near Greenhithe. It was found dead on the 8th of October after several sightings near Gravesend. The body was recovered by the Ports of London Authority, transported to a facility in Essex where we could then examine it on site before it was disposed of. The gross examination found that it was a juvenile female. It had evidence of historical entanglement. I'm about to make out on the underside of the tail fluke, see these little white lines here. That's consistent with entanglement historically in man-made gear, but that was non-fatal. There was no evidence of recent feeding, nothing in the gastrointestinal tract. It was pretty thin, nutritionally compromised, had a very heavy parasite burden, and this grim picture shows those parasites in parts of the intestine. The main finding, though, was evidence consistent with recent ship strike. This top picture here shows a large wound on the underside of the head. That's not actually the mouth. There's a large gash running along the side of the mandible. There was a longitudinal fracture of the right mandible, and also damage to the top of the head and the underside of the head. And also some hemorrhage and blood clots we observed grossly indicated that had happened before death. And the histopathology, which is something we carry out after the fact, carried out by a histopathologist here.
I found this on the web.
Bloody apple. Indicated that, ignore the terminology here, essentially what this is telling us is that ship strike likely happened 2 to 3 days before death. So when it was seen listing in the Thames, it likely had already been hit by a vessel, and sadly we're looking at the terminal end of its lifespan. So that chronicity implied that it had pre-existing injuries when it's seen within the outer Thames region. That year, 2019, we had fairly high numbers of humpback whales and a fairly high human impact mortality index over that year. So we had 3 cases of entanglement, 1 of ship strike. If you think right back to the beginning of the talk, I talked about how some of these populations are increasing in size, and that's great news. It's great to see humpbacks now more often around the UK. Unfortunately, the corollary of that is that there's more risk of them being impacted by our activities. So we may well see increasing numbers of ship strikes or entanglement in species where we see more of them around the UK. And then just to flag, we over that month, we then had a sei whale and a minke whale also found within the Thames, and there was a lot of speculation about an unusual mortality event, and I think there are separate drivers to each of those strandings. I won't talk more about those other cases here. And then most recently, we had a minke whale, fairly obviously, within the Thames. Just to recap, I'm sure everyone knows this already. Small juvenile female animal sighted in the Thames on the 9th of May, first stranded at Richmond Half Lock, which is partially exposed at low tide. Rescue groups BDMLR, our colleagues from BDMLR attended, were trying to translocate it to the location, and it escaped from those pontoons whilst being moved overnight. It then turned up the next day at Teddington Lock, really far up the river system. It couldn't go any further because of the nature of the lock, and that's the furthest any whale has ever been up the Thames. Lots of groups responding, ourselves, BDMLR, RNLI, very thankfully helping us out on site. The decision was taken ultimately, though, to euthanize the animal on welfare grounds, and I'll show you why in a second. And I believe that was the right decision, the right outcome, but I'm happy to discuss that further if anyone wants to have a chat afterwards. Post-mortem was conducted by ourselves at Whipsnade Zoo rather than at Regent's Park Zoo, where I'm based today. The animal was very thin, and this is the most obvious thing. We saw it on site in the river that day. This is the lateral process, the spine protruding really visibly, so it's lost a significant amount of body mass. So in my view, that's justification alone for the decision to put it to sleep. Had a minor parasite burdens in the stomachs and the intestine, just highlighting them here. I guess the main finding from the post-mortem, and apologies for the gruesome picture, this shows serious atrophy of fat with a gelatinous material around the heart, and that's consistent with sudden mobilization of the remaining fat reserves, and that's consistent with its entry into the Thames region. So unfortunately, it was not doing well at all. On the basis of length, doing reading after the fact, it seems very likely, because minke whales are weaned pretty young, around 4.5 meters. This animal is likely to be less than 1 year old, and certainly at or around the time of weaning. So again, to think back to what I talked about with the humpback whale, if these populations in some instances are increasing, we may well see more cases like these. In this instance, it may not necessarily be bad news. Obviously bad news for this individual, and it's a really sad event, but it may well be better news for the population as a whole. There are now commercial whale watching vessels along the northeast coast of England that weren't there 10 to 15 years ago, just because there are large numbers of whales in the northern North Sea, and that's a good thing. Unfortunately, it may well mean we'll see more strandings like these in the Thames, perhaps not less, as we move forward in time. Right, so just to recap, hopefully I'm on time. The CSIP is a long-term monitoring program with over 18,000 strandings, 4,500 post-mortems. It is biased in nature. As I said right at the beginning, it's opportunistic in nature. So it is, we freely acknowledge there are biases in the data collection, but it is also a fairly cost-effective means of investigating some of these threats. And it actually is the only means we have of assessing some threats for some of these species. It feeds into lots of work, drives lots of policy. I've given some examples here, and I'm happy to talk more about that if anyone wants to flag up more afterwards. Feeds into lots of science, feeds into lots of education and outreach. Hopefully that's part of what we're doing here this evening. We do collect data on a wide variety of man-made drivers of mortality. Sadly, we find prevented waste impact on cetaceans. For us, I think the main issues we're directly concerned about entanglement that has global impact on cetaceans all around the world, but also from our perspective, we're really concerned about the impact of disease-related mortality, likely driven by long-term exposure to some pollutants or contaminants of concern. And I guess I'll just finish by saying, rather depressingly, that for us at the Institute, PCB exposure is probably the most significant conservation concern for some species, and actually it's an existential threat, as I've said already, for some populations like that poor killer whale pod. Thanks, as always, to all our funders, all the partners, everyone who helps, including the public, yourselves that report strandings to us on a regular basis. The work wouldn't happen without your help. Thank you for listening. I hope that was of some interest, although rather depressing. And if you want to learn more, you can follow us on Facebook and me on Twitter. Okay, thank you very much.
Thank you very much, Rob. Thank you for persisting despite the couple of issues we had with connection, and hopefully people can kind of catch up with things on the recording afterwards. But that was great. It was not easy listening, I have to say, but it's a really important subject, and obviously strandings can give a lot of really very valuable information. So, you know, it is well worth doing. And there's some positive, I like the way you kind of were thinking about, you know, sometimes strandings are an indication of populations recovering. So they're not necessarily bad news. I think that is a kind of important thing to bear in mind. The PCBs legacy, you know, that issue is it's shocking, really, the impact that's having, and difficult to know what the kind of way forward is. But thank you for raising some really good issues, you know, some really important issues. There's been a lot of questions coming through in the chat, so and people saying thank you as well for the talk. What we'll do is if people would like to ask a question in person, we might have time, so please raise your hand. But if we go over to you to David, if you can pick up a few of the questions from the chat, that would be great. Thank you.
Yeah, thanks, Maria. Yeah, I'll pull a few out. So there were a few questions about the patterns of trending, which I'll pull together. So some of these are from Natalie Rowe and some of others. So are there seasonal patterns? And also a note that in the graph you showed quite near the start, there seemed to be a spike in the middle. Was that something to do with the Second World War or something like that?
Well, first of all, apologies for the sound quality. I hope I didn't have like a Dalek, and I hope you managed to hear some of what I said. Right, so to get out of the way, first of all. Yeah, there are seasonal drivers of strandings. We get a lot of winter-related mortality, which is in part driven by bycatch mortality in the southwest. I think, as I said, December through to April is our bycatch season. We get lots of animals stranding in the southwestern Cornwall in particular, with bycatch features. But we also get animals stranding during the winter because of the stressor effects of cold water. So the poor porpoise experiences a lot of stress in the marine environment. Cold water can have an additional stress, so we get lots of starved or starving animals with disease washing up over that winter period because of that stressor effect. Over the summer, traditionally, it used to be quieter. That being said, we seem to get lots of strandings around my birthday now. I'm not flagging up when it is, but my birthday is in the summer. And more recently, we seem to have had more and more strandings around my birthday. And again, why that might be is an interesting point, whether it's in some instances due to shifts in distribution over time, or whether there's some man-made drivers to those strandings is debatable. And I think the peak you mentioned on the figure, probably the annual variation, that was from 1990 to 2020-ish. So there are two broad peaks. That peak from the middle one you mentioned, we think was largely driven by increases in bycatch-related mortality in the southwest. That help?
Yep, that's very good. Let me see. Nobody's got the hand up, have them, Maria? I'll pull a few more out of this then. So there was a question about do we have a theory as to why harbour porpoises seem to be more vulnerable species to be stranded? Why we see more of them than the other species? Yeah,
I mean, I guess there's a couple of points. I mean, they're coastal. Because they're coastal, inherently we will see more strandings because they're close to coast. We get onshore winds, we get offshore winds, things don't strand, they blow them out to sea. Onshore they do strand. So it may just be randomly sampling a high proportion of the population that are closer to shore. The deep diving species further offshore, maybe they don't strand that frequently. But I guess the other way of looking at it is because porpoises are coastal, and this is the point I was trying to get at in the contaminants section, because they are coastal, they may well be increasing higher exposure to pollutants. Most pollutants are made on land and then end up going into the marine ecosystem up to the food chain. And therefore, you know, perhaps some of those porpoises will be experiencing, or used to be experiencing, higher levels of pollutant exposure, which can then drive some of the threats that we talked about earlier.
I can see someone's got a hand up. Maria, do you want to take a question, person?
Yeah, I'm just going to interrupt to say that. Yeah, so JK, do you want to just, you should be able to unmute yourself and ask your question now.
Yes, thank you. I'd like to ask about the toxic levels that were found in the species. You had them from 1 upwards. Would that be relative to the age expectation in each species as well? That is sort of, the older they are, the higher the pops, or am I reading that wrong?
No, I think that's a good point. I think it's also about trophic level. So where those animals are, I mean, killer whales are obviously apex predators in every sense of the word. They're quite long-lived. They can live to 80 years-ish. So it's a long time to bioaccumulate. The porpoise, in contrast, is quite a short-lived species, 20 years, and perhaps feeding lower down the trophic level feeds on smaller, you know, demersal fish. So that's an issue. Bottlenose dolphins, about 40 to 50-year lifespan. So they're in between. Striped dolphins, a bit of an outlier. The Mediterranean, unfortunately, has been lots of issues with higher pollutant levels, higher levels of plastics, because as I say, it's more concentrated as a shallow basin sea. And there have been lots of issues with striped dolphins as well with epizootics, or disease outbreaks. So that's probably confounding that slightly. But I think you make a fair point. I think it's largely reflecting lifespan, but also trophic level for those different species.
All right, thank you.
No worries.
We go back to the chat now, David. I think
there were a few more. So Matt asked about, is it a bit of an urban myth that the thing we hear that mass strandings are something as a result of other members of the pod searching for one that's been stranded?
No, I mean, I don't think it is. I mean, these are highly social and intelligent species. I think we've all seen pictures of those really large-scale mass strandings in Australia and New Zealand in particular. So I was at a conference a few years ago, and they were talking, my colleagues in New Zealand were talking about a mass stranding of 1,000 animals in one event in the Chatham Islands. You tend to find it's the most social species that mass strand most commonly, things like pilot whales. In fact, they're called pilots because they follow each other in a line, which unfortunately is why the Faroese can hunt them so successfully. They use noise to drive them into bays, and then everything else unfolds. So it tends to be the most social animals that do mass strand. I highlighted 4 or 5 mass strandings, I think, in my talk, 2 of which I said had an association with man-made noise. One of which, though, we think was probably linked to an adult female trying to carve actively, and because that then stranded in extremis, it's likely that the rest of the group followed in close into shore and then also became mass stranded too. And I should highlight that all those pilot whale examinations and work that was carried out by my colleagues in the Scottish Marine Animal Stranding Scheme rather than ourselves. But I think it does illustrate that, yeah, we have seen socially dependent mass strandings in the UK, as well as those that have a man-made driver as well.
Okay. Okay, let's take a couple. I'll lump a couple together. There are a couple of questions about the nature of the pollution. So there's a question from Anna about how much of the plastic is from fishing gear, and there was a question about Lulu that Sharon asked about. Would Lulu, given the amount of pollution in there, count as toxic waste if you had to dispose of her?
That's a really good question. The latter part. So yeah, deal with the first part first. So in terms of the types of debris we see in animals, yes, a large amount. And again, the numbers are low. As I said, 35 out of 1,400. So, 3% of cases we see plastic in them, but we certainly have.
I think we might have lost Rob again.
Yeah, we've lost you, Rob. Your sound,
Yeah.
Rob.
He seems to have vanished from the.
Okay, we'll give it a minute or so just to see if he can get back. If not, what we are going to do is we're going to he said he will kind of follow up with any questions that are outstanding. He's happy to take an email with them in, and we'll get some answers and then circulate them to everybody. So if we can't get him back, all is not lost.
Equally, I've seen. Okay, can you hear me?
Yeah, I think you're back.
I'm back.
Yeah.
Can we try about that? Is that any better?
Yeah, we can hear you.
Sorry, can you please repeat your answer considering fishing gear in the plastics, because the connection broke off?
Yeah, sorry, Rob. I might just suggest turning off your video again because it did help last time.
Hello, am I back in the room?
You are back in the room.
Awesome.
So we basically didn't get anything on the answer to the questions about fishing gear and toxic waste. That's when it started to break up.
All right, probably press the mute because I talk nonsense. So yeah, a short answer then before I go again. We do see fragments of fishing related gear in some animals we examine, but the numbers are low. But then we've also seen some fairly unusual man-made material in stomachs too. So we've seen cotton wool earbud in the esophagus of an animal. You see crisp packet fragments. I found a wrapper belonging to a well-known supermarket brand, mention no names. So you find all kinds of stuff. And I think the other question was quite interesting about toxic waste in killer whales. It's a really good question. The answer is I don't know. I'm aware that PCBs are treated quite more seriously across the EU, perhaps than other countries. So some countries do more than others. Could you make an argument that animals should be disposed of appropriately? The only way to get rid of PCBs forever is to run them through a really high temperature incinerator. The only one we have in the UK is, as far as I'm aware, is the steel factory in Port Albert. So I don't think they're going to entertain the idea of us disposing of killer whales in their steel factory. But it's a really good point. They're more carefully. Something to think about.
We'll take one more, I think, Maria, if that's okay. Well, a group of questions from people. So there was a specific question about if somebody wanted to do a PhD in this area, where would they get involved? But more generally, there were a few questions about people wanted to get involved with and do things to help with this work. What could they do?
Okay, so the first part first, it's obviously very competitive. People let go of the jobs with their cold dead hands because there's not a lot of jobs out there. But what we always say to students is if you're really interested in pursuing a career, it's hugely worthwhile. It's endlessly fascinating for me personally and for our colleagues. So there are two mailing lists you can join on to. There's one called ECS, European Cetacean Society, for our colleagues across Europe. You can join on that, and opportunities do come up on the ECS mailing list. There's a global one called MARMAM, M-A-R-M-A-M, which is the more global mammal community. And I have seen opportunities come up on that as well. It is difficult, it's very competitive. Quite often you have to pay to do internships rather than the other way around. But I do know people that have pursued it through that route and now have careers in mammal science. So you can go down that route, and it is worthwhile doing. And what was wrong again in the second part? Sorry, David, it was a
more general question about how could people get involved in this work and support what you're doing and so on.
Well, I said at the end of my talk, we depend on the public reporting strandings to us. You know, if it hadn't been for the help of all members of the public walking their dogs, reporting things through very circuitous routes, we wouldn't get to a bit where we are now. So if you do find a stranding, if it's a live stranding, first of all, report it to our colleagues at BMLR, RSPCA, other rescue groups, and they can respond to it, hopefully effect a rescue or deal with it appropriately. If you find a dead animal, obviously notify ourselves. We have a hotline which I can report through the group back to everyone else. And beyond that, I think, you know, it's we depend on the public in terms of funding. You know, we're funded currently by UK government. They're very supportive of our work. I guess it's always useful to let your MPs and your politicians know that this sort of work is valuable, which then keeps us going. Beyond that, you know, in an ideal world, we could be having this talk in person. We could then go down the pub and carry on this conversation. We can't do that right now. So I hope as we move forward into a more normal world, maybe the more opportunities to actually meet face to face and have more discussions and carry on these chats beyond over my screen, which doesn't work very well, obviously.
Thanks ever so much, Rob. That's quite a good thing to, and you know, maybe we'll think about inviting you back in person at some stage. I mean, I'm sure it'd be, you know, to talk to the society again at some point. So thank you very much, though. Thanks for bearing with us with the technical stuff. It's been a really fascinating talk. We've had a lot of positive feedback, you know, people saying thank you so much. They've found, you know, found the talk really interesting, and it's obviously stimulated some people's interest, maybe even kind of, you know, pursuing this further, you know, as a study or maybe even as a career. So we'll try and circulate those details to people in when we send out the follow-up email. And I know there were a few questions we didn't get to, so Rob, if you're happy to kind of like give us some answers to those, I can circulate that as well. Thanks ever so much to Rob for a great talk. Thank you to everyone for coming and taking part. Our next talk will be on Thursday, the 8th of July, and that will be Dave Dawson talking about bird censuses in gardens and his 33-year study of the birds in his own garden in southwest London. So again, that should be a really interesting talk. It's the second in our series of talks that are planned jointly with the Ecology and Conservation Studies Society, so please do sign up and join us for that event. See our website for details of all our talks and sign up to the mailing list for virtual talks. We hope to see you all again soon. You can unmute yourself if you'd like to say goodbye. Fingers crossed that the technology holds together that long, but you know, do that if you'd like to. Thank you ever so much for coming, everybody. Nice to see you all again, and hope to see you all again very soon. Again, lots of
Bye. Could you
Bye.
please maybe leave Rob's contacts, so just in case we can contact you for any more questions?
Yeah, Rob, would that be all right if we could have some kind of contact?
Yeah.